Swayam Prabha. Digital India. Educated India.
Namaskar. It's really a great pleasure to talk about the Engineering Excellence and Cultural Heritage Center, Shri Temple at Ayodhya. This is not just a temple, it is more than a temple, because the it is a civil engineering marvel what has been constructed. Today I am going to briefly touch upon what all the aspects which has made this temple a very unique and very significant civil engineering infrastructure in our nation. Friends, I titled my talk as Engineering Excellent Cultural Heritage Center as it was introduced because it's a dream of billion people, and many have already visited the site, and it has become an important site in India for sightseeing as well. So many have visited and taken the blessings of Ram as well. Today I'm going to talk to you about the civil engineering constructional aspects of this temple. The site, what is being shown here, the temple is a beautiful temple which is depicted right here in the picture, which clearly shows that it is at a level higher than the ground elevation level, which has been scientifically designed, and every aspect of it is as per Vastu Shilpa Shastra. And when we got into this project was when L&T started a pile foundation for this temple. Larsen and Toubro and Tata Consulting Engineers were actually designing the entire temple, and when they started looking this as an alternative foundation, as a pile foundation, which is basically a long cylindrical structures made up of strong material placed in the soil to evenly transfer the load from the superstructure. I wanted to give today's talk as simple as possible so that even a non-expert in civil engineering should be able to understand this talk. This temple is only 3 floors. If you look at that, and still a pile foundation was preferred. But all the piles which were casted, at least 6 piles were casted at the site, and these were fixed, and 5 samples were tested with a load simulating the conditions of what would be the actual load like on the pile foundation. Somebody was whispering to sir that out of the 5, 3 have tilted a little bit and failed. So it is basically, you could see the message, what I have posted there on the right side of the slide is from Sri Nupendra Mishraji, which appeared in the Indian Express on May 30th of 2024. That's the peak COVID time. During that time the construction was happening. So during this time, what happened is the pile testing was done and the pile foundations were considered as failed. So then government constituted a committee of experts, and this committee of experts looked at all the pile foundation results and looked at why it failed, because the entire material below the Ram temple foundation was a filled up ground, and characteristics was very, very loose, and it could not take the both vertical and horizontal load which are applied in the pile. So at that time, an expert committee, 8-member expert committee was made, chaired by Professor Raju, former director of IIT Delhi, to look at how this could be looked at it and what kind of solutions we can put for this temple foundation. And also time was very little. So if you look at, there are many people involved in this project, which I would like to highlight, other than the 8-member expert committee chaired by Professor Raju, where I was also one of them. And the L&T Geostructure LLP was the construction company. Central Building Research Institute and National Geophysical Research Institute had conducted geotechnical and geophysical investigation. IIT Madras extensively worked on the backfill, which is going to be considered later on why the backfill was needed and why this material has to be designed very uniquely for this temple structure. And then many other engineers, consulting engineers and architects have gone to look at the quality of the project. And the unique architect of this project was C.B. Somapura, who is an expert on temple architecture and constructed many temples. And St. George Geotechnical has done the investigation, which is from Delhi. So this was the composition of the committee. You could see who is who in the geotechnical engineering and also structural engineering are there for both from industry and the academia. Just to name, Dr. Gopalakrishnan was the director of CBRI, Professor Gandhi was director of NIT, and Bhattacharya ji is the professor of IIT Delhi. Maypi Mal is from Tata Consultancy Engineering, Pradipta Banerjee, former director of IIT Roorkee, and Manu Santanam is a professor from IIT Madras. So the terms of reference to the committee to look at once the pile foundations have failed, look at the soil investigation carried out by different agencies at the site, and give a recommendation of what best suits for this particular site, considering the time as well as the planning of the entire project and which needs to be designed for a very long time. So temple at Ayodhya is a historical for many of us because it's a 500-year-old stigma which is erased on 9/11/2019. So you could see the timeline. So almost like 1528 to 1529 when Mughal Emperor Babur builds a Babri Masjid on this temple site. The fight for reclaiming for a temple site has been going on for a very long time. Many court cases had happened, and finally the decision was at 2019. Supreme Court of India accepts Ayodhya was the birthplace of Lord Ram, and it has handed over the site, entire site, the line, to the Rama Janmabhoomi site. And 2020, Honorable Prime Minister Narendra Modi ji performs the Bhumi Pujan and lays the foundation stone on August 5th of 2020. 2024, we are on January 22nd, that is last year, on the same day, Prana Pratishtha of Ramlalla happened. And it's a very unique project from a civil engineering point of view. And we are going to witness what stages of construction this site has taken place and how the entire structure was completely constructed. I'm going to give you on that aspect. This is the temple view from inside where Ramlalla has been. This is the sanctum sanctorum of the temple. So many of them have contributed to this project. I would like to thank everyone who is part of this project. I would like to thank and place on record their contribution to this temple site. Just to give you the features, it's located in a site of 380 feet by 250 feet base width, and it is tall, 161 feet tall temple. It is located in a site of 70 acres where 70% is kept for green area from a civil engineering point of view, and it has 5 mandapas with main entrance on the eastern side. Entire temple is constructed in Nagara style of architecture. There are totally 392 pillars, both at the ground floor and the first floor adding. You can see the number. No steel or iron has been used in the temple. Copper chips have been used to connect the beams to columns and other things. And its total cost estimated was 1800 crores. And the major sandstone was used as the pink Bansi Paharpur, so which are actually brought to the site. Once it is assembled, carving has happened. And you could see the beauty, the grand beauty of this structure today. Traditional construction materials and age-old building practices have also been followed here. So very unique learning and innovations has happened in this project construction site. Granitic stones of almost 21 feet tall for plinth are used for plinth slabs to raise the entire temple basement to a higher level, so that you have a plinth of that to protect it from flood control and many other issues. Foundations of 14 meter thick below the Garbhagruha and 12 meter in the other area using roller compacted concrete almost creating like an artificial rock below the temple is existing, which is very unique of this project site. Structural integrity has been tested against maximum considered earthquake, equivalent to a seismic event with a 2,500 year return period. So the project brief is the grand structure is being built to have a lifespan of more than 1,000 years. Built in the Nagara style, as I told earlier, and protection against ground moisture. That's where moisture as well as flood control. So 21-foot high plinth has been constructed with granite. The core of the temple is built using pristine white Rajasthan Makrana marble. On the other hand, pink sandstone from Rajasthan's Bansi Paharpur has been used in the entrance gates, imposing figures. Black stone used for Lord Ram's idol originated from Karnataka. From the Himalayan foothills, Arunachal Pradesh and Tripura have offered intricately carved wooden doors and handicrafted fabrics. So it's all materials, civil engineering materials have come from different parts of India. So brassware has helped from Uttar Pradesh, polished teak wood has been sourced from Maharashtra, built using Indian traditional and indigenous technology, and many experts have been contributed to the construction of the temple, and still we need to build the temple complex, which has a very unique sewage treatment plant, water treatment plant, water supply for fire safety, and independent power stations, all are being planned. So it's going to be a very unique project once all components of the temple complex is completed. So coming back to the site itself, the subsoil, as I told you, is underlined by a filled up soil varying from 7 to 15 meter height below the existing ground level. Throughout the site, followed by a dense silty sand. So this is actually there in entire Indo-Gangetic belt. This dense silty sand, because it is almost like, in every site of Indo-Gangetic plain, you will have a similar kind of a material. So groundwater table is observed at about 15 meter below the existing ground level. During the investigation, it was also observed. However, temple is approximately 1 kilometer away, aerial distance, from Gagra river, which is Sarayu, also called as Sarayu. So possibility of rise in groundwater table and floods in the future. So this is a very, very critical aspect while designing the temple. That's where the plinth has been raised. So groundwater table is considered as the high flood level, which is 94.01 meters from the corresponding levels. So we have taken every aspect of design, including risk of liquefaction at the site. So I myself visited on 13th December. You could see that was after the COVID period, and at that time the site was like this. You could see drill rig were ready to drill the piles, and the site was excavated partially for the inspections, and this was the visit of the site which happened in December 2020. And this is the temple which is planned to be constructed at that particular site. Okay, this is a three-dimensional view of a temple. Very clearly you can see it is a plinth level is higher at the bottom. So this is the 3D view of the same temple in a perspective view. So the location of the temple, if you can clearly see, it's about 2 hours 30 minutes from the city of Lucknow, and in a city called Ayodhya, and Sri Ram Janmabhoomi site is located very clearly, and you could see the Gagra river, which is also called as Sarayu river, which is the location of Ayodhya temple. So it's about 1 kilometer away, and the entire area is completely habited already, and a lot of houses and residential buildings exist in between. And explicitly the site, at the site, the main temple, if you plot it, that's where the main temple is there. The entire site is today about 100 acres. That time it was about 67 acres. So the ground also varies. So this is the cross section of the ground level. Very clearly see that the temple is on a mound, actually created on a mound. So you could see both the cross sections, and the temple was a green point what we have shown. So it is on a mound. So that is an excellent site from the consideration of the ground moisture as well as the high flood levels. So the temple layout superimposed over a survey plan, we can very clearly see how the contours are varying at the site. These are the reference levels which you can see, and the temple is being marked on that particular site, and the dots are the pillars which are going to come. The different cross sections of the temple site, overall plan is being shown at different level: ground floor, first floor, and the second floor. Okay, so very clearly visible here, and this is the plan of the second floor, where as we go up, the area is reducing. So this is the total temple site is about 116 meter wide and 70 meter wide at the maximum points, and the temple entrance is located in the eastern direction. So the owner of this temple would be Shri Ram Janambhoomi Tirtha Kshetra, and the project management consultant is IIT Management. Temple architect is Sompura Architect. Project title is Engineering and Construction of Ayodhya Complex, Ayodhya, Uttar Pradesh, and location is very clearly given, and at that time it was 67.7 acres. Some additional land is been also acquired now, and nearest city is Lucknow and Faizabad. L&T Geo Infrastructure is constructing. So coming back to the geotechnical investigation and foundation system, the project site is filled up soil from 7 to 15 meters. So a lot of investigations have happened. I will not get into the details because this is for a general talk, and many investigations both using geotechnical as well as geophysical, and one of the best of the best institutions in the country have been used to create these data. So the very unique geotechnical and geophysical data has been created for this particular site, and these are the locations of the borehole and also where the pile tests were conducted have been clearly given, marked here in this picture. And what it clearly shows that this site is very well studied and understood. And these are the trial pits, very clearly indicating what kind of material which is there in the ground. And this is very close to the top because pits were only could be done 2 to 3 meters below the existing ground level. So these are the trial pits where we have seen. And these are the bore logs where very clearly shows that the 7 meter to 15 meter, the entire thing is a fill of a very loose soil fill, and which is varies from the east to west and north to south of the site. Okay, very clearly done. So this is the location where it is in the floodplains of Sarayu river or Gagra river, and meandering, because river might have meandered also at this site. Maybe one time the temple site was located on the banks of Gagra river. The Sarayu river has a huge large floodplain in this location, which with mid-channel bars and channel meandering with multiple meandering scars within the floodplain. Ayodhya, the temple, is located in the elevated ground beyond the active floodplain. That's one thing I would like to highlight. As I told you in the cross section, this is on a high ground. The temple site lies adjacent to the cutoff bank to an abandoned meander of Sarayu river. That means there is a very less chance of the meandering cutting into, even if it happens over another 1,000 years. There is a natural depression of paleo channels. That means there was a suspicion that there could be these channels below the ground, or this temple site could be extending. So a lot of investigations have been done using ground penetration radar, and NGRI, National Geophysical Research Institute at Hyderabad, has carried out very serious investigations of looking at distributions of buried cultural artifacts and structures at this site were noticed in a form of a well-formed structures. Several buried wells extending down up to 30 meters were also identified at the site, including one under the Garbhagriha with a damaged well lining was also found. Deep resistivity sounding and electric resistivity tomography and multi-channel analysis of shear wave survey had been conducted at this survey. Some of these results very clearly shows that the assumptions of 7 to 15 meters of a filled up soil was uniquely captured in three-dimensionally at this particular site. So the multi-channel analysis clearly shows non-existence of the erosional channels at this particular site. So, and also IIT Roorkee and NGRI has also carried out earthquake hazard studies with micro tremor, because one of the major maximum loads can come from the earthquake which can happen at this particular site. As this site is about 500 to 600 kilometers from the main boundary thrust of the Himalayan foothills, so that we need to build cautiously this one for a maximum credible earthquake which can happen at that particular site. Please note this. This site is about 500 to 600 kilometers from the main boundary thrust, which is Indo-Australian plate, which is moving against the Eurasian plate, which created the Himalayas. That site is very close by, so large earthquakes can happen at this site. So we took care of that studies using the both earthquake engineering department of IIT Roorkee as well as the National Geophysical Research Institute have done extensively and classified this site as class C and class D, which can be prone to liquefaction during an earthquake. So transfer functions are also clearly highlighted. The frequency ranges could be on the range of 0.3 Hertz to 4 Hertz. Response spectra was also calculated. So here what I would like to highlight to you here is we have looked at the temple structures likely to have a natural frequency about 0.3 to 0.6 seconds. So there could be a possibility of frequency range of the amplification of the ground motion also in this range. So there could be a possibility of amplification and site liquefaction as well, because it is below the groundwater. So we asked to conduct many new geotechnical investigation at this site. So large number of geotechnical investigations were conducted. And I would like to also highlight on the loads on the structure which is going to come and what are the alternatives committee considered. So if you look at the loads coming on each part of the temple structure, the maximum load was coming at Garbhagriha, which is about 40 ton per meter square, and the next is the Gudamantapam with 32 ton per meter square, Rangamantapam, that is the dancing mandapam, at 30 ton per meter square, Nritya Mandapam at is 27 ton per meter square, and a podium is at 18 ton per meter square. So this is where the Garbhagriha area is the area where a very high intensity of load is being applied, and that is where we also found some of the artifacts and wells at the geotechnical investigation. So if you can look at the foundation and the actual dead load combination, so it was thought that a shallow foundation should be sufficient. And also committee looked at the temple across India and how these temples were constructed. Majority of the temple, leaving out maybe one or two temples elsewhere other than in India, all of them has used a shallow foundation on improved ground, including our oldest temple, which are in Tamil Nadu, 1,000 years and beyond that which has existed, are also on shallow foundations. So the idea was, I thought the pile foundations which were adopted may not be the ideal scenario for this project. Maybe we should excavate the ground and improve the ground, put the temple on a shallow foundation. So this is what the gut feeling of the temple site. So it should be on a shallow foundation, on a raft kind of a foundation, so that the differential settlement is not there. So it is a one single foundation at the base, so that no differential settlement occurs, because the temple superstructure is very, very critical. Why? Because this is only an assembly of the beams, columns, and they have put together. There is no steel also used in this structure. So that's very, very vulnerable for any differential settlement from one location to the other location of the temple site. So foundations of Ram Janmabhoomi temple, now what we thought, what myself thought on this should be a raft foundation on an improved ground. Considering that the designs need to address design life of 1,000 years for the foundation and structure, very important foundation design aspects have been listed down. One is the differential settlement close to 0 or less than 12 millimeter, and ensure safe transfer of superstructure loads to founding strata, which is vertical, downward, upward, and horizontal loads to be considered even during a worst seismic event at that site. Ensure durability of the foundation material. The foundation material what we are going to put back at the site should be also should not be subjected to weathering, and also it should absorb any effect of underground water currents at that particular site because of it's close to the Gagra river. So the requirements are very, very clear that allowable foundation settlement should be 12 millimeter due to temple column superstructure, because temple column superstructure is very connected beams columns without any steel reinforcement. Differential settlement along foundation should be negligible. So many alternatives were considered by the engineers and the designers of the construction site. One, we have also looked at the alternatives: raft foundation resting on soil, raft resting on piles, raft resting on grouted columns. Many such alternatives to create a confinement so that the entire site is safe from any movement of differential settlement. So many alternatives you can look at it, whether it could be a pile foundations or pile raft foundations or shallow foundations, all were considered and analyzed. Very detailed geotechnical finite element type of analysis have also been carried out at the particular site, even including a diaphragm wall all around the temple site. Then finally the decision was, see, this is the report I submitted to the committee, very clearly highlighting the temple is located on a natural mound about a kilometer on a filled up soil, which is created over a period of time, because the elevation is higher but the entire soil below is very soft and filled up over generations of construction which has happened at that particular site. So the fill is mixed with the concrete, many materials, civil engineering materials, because of the earlier constructions. And considering all of these, what our recommendation was, considering the nature of superstructure, load distribution, longevity, groundwater table, ground conditions, it is very difficult to simply go with deep foundations. It's better to know what exists below the ground, maybe remove all that material, reconstruct the entire site with an improved ground, and put, as we know the knowledge about the shallow foundations much better, so put a shallow foundations on the reconstructed ground. That means we need to excavate the loose soil in the area, fill good permeable sandy soil or good material as designed by the engineers, and adopt a ground improvement appropriate to the site. And all this has to be done against the timeline. See, the time was very short, because before the monsoon kicks in the month of June, July, this has to be done. That was the critical aspect of the decision making, and thanks to the entire committee which looked at it. And these are some of the correspondence which I had. So the alternative suggested by the committee, 8-member committee, was option A, ground improvement by vibro stone column; option B, open excavation with engineered backfill. So these two options came because of the differing views within the committee, and experts had a different opinion. Finally, I actually opined that open excavation and engineered backfill would be ideal, which is well engineered material has to be put below the ground and use that aspect to the ground. So considering this, that the committee deliberated, and temple authorities, administrators, everybody has consulted many, and finally took a decision to go ahead with open excavation with engineered backfill in a very scientific way. That's what I wanted to highlight about the civil engineering marvel of this particular site. Finally, committee also agreed this could be one of the alternative, and finally the temple authorities chosen the option B, open excavation, create an engineered backfill, and this is what has been done at the site. And the other option was as I told you, the ground improvement by vibro stone column, where we didn't have a chance to see what exists in the ground. We would have lost many of the artifacts which were found due to excavation, would have been completely vanished, and we couldn't. The open excavation started on 29th of December. The decision was taken to adopt open excavation. The construction committee trust later met to deliberate on the choice of technology and related matters in the background of the expert committee recommendation. Committee decided to favor the option 2, open excavation process for foundation structure of the temple. So committee directed Messrs. L&T should be requested to design the foundation structure on open excavation on a shallow foundation. This is exactly, and TCE is actually looked at all the aspects of this, and come out. So what it means is the solution is like this. If you look at it, the natural ground up to about 7 to 715 meters was a very weak soil. So the entire ground would be removed and improved ground will be created from the plinth level and construct the temple, and the temple will be assembled. So very clearly the concepts are justified, taking into account the ground conditions, structural and serviceability requirements of the buildings and economical factors. Time is also very important. So let me give you the construction plan which was executed at the site. Excavation for foundation was started in January 2021 to March 2021. See, another 3 months they have to complete the filling of the site. So the backfilling and the engineered fill started in April 2021 and completed September 2021. Luckily, we exceeded beyond even July, the monsoon, but we could survive because of the monsoon was not that severe. So construction of the wrap between September 2021 to November 2021. Construction of plinth happened with using the granite flats, which is about 21 feet high, from November to March of 2022. So you could clearly see that temple superstructure, this was year 2022. So temple superstructure column started on January 2022, completed by December 2022. So that means superstructure took about a year's time. Okay, and the excavation for foundation, you could see the entire site was excavated, okay, about 14 meters below the Garbhagriha and 12 meters uniformly across all the other site. And these were the ramps which are created for moving the vehicles and removing the soil from the site. And these are the kind of slopes which were adopted at the site so that it is a safe slopes while excavating or also while constructing, while filling up the entire material into the ground. So we have done all the analysis what is required. Even the agencies have done independently. So many of them, so 12 meter with 3 meter berms of 3 meter, 6 meter and 9 meter were enough with a 1 vertical to 1 horizontal excavation, and we had a very good factor of safety. This is the site excavation which started at the site, and these were the remnants of the test piles which were created at the site earlier. So we can clearly see the excavation, how the proceeding, and as I told you earlier, the next question is the fill. What is the engineered fill? IIT Madras has designed this. There were 3 choices. That is, the roller compacted concrete was the choice being adopted. They could have used the same soil, filtering out all the bricks and other things created, but the final choice was actually the engineers at the site have decided to adopt the roller compacted concrete as designed by IIT Madras. And the engineering, the characteristic of the material to obtain this designed rock-like properties was possible using this technology. The design procedures and test method for the same will ensure the production of consistent material quality for all the layers, okay, and that was adopted. There were other 2 options where this was not guaranteed. So roller compacted concrete mixture for the fill, which will be designed by the IIT Madras. There are a lot of testing has happened. Laboratory trials would also been done before recommending at the site, and even at the site tests were conducted. So during construction, the contractor should perform field density measurements and core extraction of the plan testing, and frequency was also indicated clearly at this particular site. So you could see some of the pictures how the compacted layers were done, different layers, and the challenges were how to place this consecutively, continuously, at a layer thickness of 250 millimeter. So that was the big challenge. But anyway, you could see the site was constructed. How did they do that? Fill multi-layered foundations, 56 layers of this roller concrete was placed. 56 layers. That means in 5 zones each. The entire area was divided into 5 zones, and compacted concrete was placed in 5 different zones. After that, 21 feet high plinth was loaded on that with 23,000 plus granite stones of 5 feet by 2.55 by 3 feet, 3 inches. So 3 tons each of these granite stones were in 7 layers interlocked so that doesn't move, has been placed at the site. So completely the foundation now today is consisting of an engineered backfill. which has a soft rock-like structures and which is designed by IIT Madras team. Well-graded compacted granular fill, well-graded cementatious compacted granular fill are the alternatives thought about, but finally what has been adopted I have highlighted. So some of the technical details, what should match, was also given. So the post-open excavation and backfilling, we had some challenges. Many people have visited after the construction. Professor Raju has visited, and he clearly highlighted that the entire settlement was about 4 millimeter after the observation. That's what he wrote to me through an email. These measurements confirm that foundations as adapted are adequate, satisfying all safety and functional requirements. Between the two options of ground improvement by vibro stone columns and open excavation was chosen here, and which was worked very well at this site. And another important aspect is these open excavations revealed many artifacts at the site, because you could, when you open it, you found all those artifacts which are dating back to thousands of years, which would have been lost if we had adopted a deep foundation, either a pile foundation or even a stone column. So this is very, very unique, and this was also been observed during the archaeological investigation at the site, which was only done by 100 feet by 100 feet. So now entire Janma Bhumi site, particularly the temple site, is excavated. So there was an ample opportunity to find excellent artifacts, and some of them were found and they've been dated back to Krishna period and in the temple foundation dig. So this archaeological artifact unearthed during the first year of deep foundation work for the Ram temple in 2020 and again in 2021 revealed evidence that goes back to Krishna period. I don't want to say beyond this. These are some of the artifacts which are found at the site very categorically. Yeah, and this is the temple construction now begun, superstructure. This is the beauty. The superstructure has been constructed after the foundation has been done, and the pillar connection, beam connection, slab connections, you can see they are only having some copper clips, nothing else, no steel. They are all glued one to each other. That makes the structure very unique superstructure. That's why we need to be very careful with the foundation. So the foundation design is very critical at this site. So this is the beauty of the temple at the end, which has been constructed. Still work is going on the entire temple site. We had an opportunity to go there on 22nd of January last year, and 1 year has passed, and it's really a proud moment for all of us Indians that the beautiful temple is there. I would like to just show you a video recently when Shri Champat Roy ji met me in Ambedkar Bhavan. He made some remarks on the temple site. This was in Delhi, and I will only show you where he referred our aspects of it due to lack of time. Okay, this was done in Ambedkar Bhavan on 2nd of May of 2024.
मैं यहाँ एक परिचय और करा दूँ. हमारे बीच में बैठे हैं सीताराम. ये प्रोफेसर हैं, डॉक्टर हैं. देखते ही मुझे याद आ गया, नाम बोल दिया मैंने. ये IIT गुवाहाटी में डायरेक्टर थे कोरोना काल में 2021 में. समस्या खड़ी हुई, 1000 साल का मंदिर है तो इसकी फाउंडेशन कैसी होनी चाहिए. लार्सन टुब्रो ने फाउंडेशन के बारे में जो सोचा, उसका ट्रायल अप टू द मार्क नहीं आया. सब चिंतित हो गए. तो देश में जितनी IIT, दिल्ली, गुवाहाटी, बम्बई, चेन्नई, CBRI रुड़की, NGRI हैदराबाद, लार्सन टुब्रो, टाटा, इनके सब बड़े बड़े स्ट्रक्चर इंजीनियर्स, IIT गुवाहाटी के डायरेक्टर, IIT दिल्ली के रिटायर्ड डायरेक्टर, NIT सूरत के डायरेक्टर, CBRI के डायरेक्टर. अब कोरोना तो सब ऑनलाइन मीटिंग होती थी. इस कोरोना में इन्होंने कहा मैं तो साइट विजिट करूंगा और अकेले करूंगा, मेरे साथ कोई नहीं चाहिए. अभी कोरोना में कुछ हो गया तो क्या होगा इनको. और ये साइलेंटली अयोध्या में और जन्मभूमि में प्रवेश कर गए. सब कुछ देखते रहे, पता नहीं क्या देखा. और इन्होंने एक इंडिपेंडेंट रिपोर्ट लिखी कमेटी से हट करके, ये होना चाहिए. वही किया गया। 1000 साल आयु अगर पत्थर की है तो उसके कंधे भी उतने ही मजबूत होने चाहिए, अर्थात फाउंडेशन भी वैसी होनी चाहिए। आपकी रिपोर्ट।
So thank you everyone. What basically, what I wanted to highlight after completion of a year of the temple construction is, it's a very unique civil engineering structure. Lot of input of lot of experts from across the disciplines. A multidisciplinary approach has been adopted in designing the temple foundation on which the superstructure has been constructed. Very unique structure, very unique temple. I think more than, I can call this as a civil engineering marvel. That's all from my side. Thank you very much for patiently listening to me. Thank you. Namaskar. Jai Hind. Jai Bharat.